Okay, this is from the bearings worksheet question 8. Interestingly enough, it's got nothing to do with bearings, but anyway, you can see here that we've got the climbing wall here. We know that the climber's made it some way up the wall. He's got 10 metres to go, and we're wanting to find how far he's climbed already. We are given that it's 45 degrees to the top of the climbing wall, and it's 30 degrees to where he currently is. And that's our X. You can see I've used colours there to help me see the right angle triangles. There's 2 of them. And I'm going to use every bit of information that I can possibly find out of that to get some equations. So let's look at this green thing here. Clearly this is my opposite, but I have absolutely no idea of my hypotenuse, and I've got an angle. The one thing that I can see here is that the length of my green horizontal line and my black horizontal line, it's the same line, so it's the same distance. And just because that's the adjacent side to both triangles, I'm going to label it A. I have no idea what A is, but it's the same in both triangles. So I'm going to come to my green triangle. So this is my O, and that's my A, and that's my theta. I'm going to go tan 30 equals O, which is X on A. Fair enough. Okay, let's look at my black one. My black one has an angle of 45, so tan 45. Now my O is actually that whole length there, so it's X plus 10 on A. So pretty much from here I can ignore that whole diagram because I've got 2 equations here and I've got 2 unknowns. I've got an A and an X. If I've got 2 equations and 2 unknowns, I should be able to solve it. So clearly I want to have X equals by the time I get to the bottom of the page. So we'll want to make A disappear. So let's look at this A here. Let's start with the green one at the top. Okay, if I put the A up there, I'm working across the page, which is a little bit naughty, but gives me more room down here. I'm going to put the A up there equals X on tan 30. Hopefully you can see that that's nice and easy to do. And I'm going to get my A here. I'm going to flick it up to the other side and go X plus 10 and get the tan 45 underneath. So I've got 2 equations with A equals. By substitution, if that A and that A are the same length, then I can say these 2 are the same as well. So that's substitution. So I can go straight to X on tan 30 equals X plus 10 on tan 45. And all of a sudden, all I've got is an equation with X's in it. Okay, I want to get rid of this tan 30. So let's multiply both sides by tan 30. And I might as well get rid of that at the same time. So how about tan 45 times X equals tan 30 times X plus 10 times tan 30. Now, if you're in grade 10 or 9, then by all means we're going to go tan 30 is 0.577 and tan 45 is 1. Tan 45 is 1. If you're looking for an exact answer, we're going to use exact value triangles, which if you haven't got there yet, it's okay. Just use your decimals. So tan 45 is 1, so I'm going to go X here. Tan 30 is actually 1 on root 3 plus 10 on root 3. So let's get the x's together on the other side. And so it's going to be 1x minus 1 on root 3x, which is 1 minus 1 on root 3x equals 10 on root 3. Let's think of that as subtracting with fractions, so I need a common denominator. So that's still 1 minus 1 on root 3. So that's going to be root 3 minus 1 on root 3x equals 10 on root 3. If I multiply each side by root 3, can you see what happens? Those root 3's just disappear. And because I'm running out of room, I'm just going to make them disappear like that. And you can see now that x will equal 10 on root 3 minus 1. Still not happy with that because there's a surd in the denominator. So you'll see in the answer section that that's one option, but my preferred option is that you're going to rationalise the denominator and you'll end up with 5 root 3 plus 5. If you're not sure, I'm just a little bit out of room and out of time. If you're not sure how to do that, go back to your surds chapter and work out how to rationalise that denominator. But this lesson was mostly about that trig, making sure that we can use complex trigs, and if it spits out to simultaneous equations, we've got that skill as well. Okay, that was a nice hard one. Go find some more.